knowledge, I am going to explain spread spectrum modulation. Previously, we have seen many techniques that are more concerned about the transmission bandwidth as well as the transmitter power. We have many applications where we need to concentrate more on the interference and the unwanted receivers who are blocking the information. So unauthorized receivers are receiving the original information. So this type of the communication is called as secure communication. So here the important applications of this spread spectrum is used in the military. Not only in the military, for the non-military applications also we can use the spread spectrum. For the non-military applications it is interference. So we need to avoid that interference. Why this interference is occurring? Well, because other users are intentionally transmitting through the same transmission channel, then you will have interference. And this interference is also happening when intentionally when you are jamming the signals. So you will have the interference. So this interference problem can be avoided by using direct sequence spread spectrum. So you can define the spread spectrum in two ways. One is the transmitted sequence, data sequence is much more, is having a bandwidth that is much higher than the minimum transmitted bandwidth, and you are spreading the sequence at the transmitter side and de-spreading the signal at the receiving side. So we are spreading and de-spreading. This is done by using the special codes called as pseudo noise sequence. Pseudo noise sequence which is generated by using a pseudo noise generator. This pseudo noise generator is nothing but it is a shift registers. Shift register, that is a linear feedback shift registers. Next is, so these are the definition of the spread spectrum modulation, and you have the important applications of the direct sequence spread spectrum is military, police radars, coordinate phones, cellular phones, GPS, Bluetooth and wireless. And this Bluetooth is an application of frequency hopping spread spectrum. Coming to the military application, when in the military application, when the enemies knows the frequency band in which we are transmitting the signal, so intentionally he will be transmitting the signals in order to jam our original signal. But by using this spread spectrum modulation, when you are, so in this spread spectrum modulation we are using that PN sequence. So by the PN sequence we are converting the narrow band signal into wide band signal, so that the signal is spreaded. So the enemies, they cannot identify our original information. So in this way we can use this application in the military, and these are the different applications. And you have different types of the spread spectrum modulation. This is a direct sequence, frequency hopping, time hopping, other one hybrid. Hybrid is nothing but you can have the combination of these three. Direct sequence spread spectrum. See here, we can have this spread spectrum for analog signals or digital signals. If it is analog signal, for the direct you can use AM or PM, that is amplitude modulation or phase modulation. If it is a digital signal, you can use ASK or PSK. Coming to the frequency hopping spread spectrum, if it is analog signal, you can use frequency modulation. If it is a digital, you can use binary FSK or MRA FSK. I am explaining about the direct sequence spread spectrum modulation. This is the transmitting side. Whatever transmitter your binary data is there, that is modulated by using the PSK, that is binary PSK. So here, what is the binary PSK? What is this PSK modulation? This is nothing but when you are transmitting 1, then it is the phase shift is 0. When you are transmitting 0, the phase shift is 180 degrees. So this signal is represented as SG of t. This is once you are modulating the signal. So this again, whatever modulated signal is there, the signal you are modulating again by using pseudo noise sequence. So which is generated by a pseudo noise generator. So here whatever the two signals are multiplied here. So this function we are calling as direct sequence spreader. That is nothing but it is spreading that sequence. That is narrow band signal is converted to wide band signal and you are transmitting the signal. This is the receiving side. This input signal is the direct sequence spread spectrum signal multiplied with the PN PN sequence multiplied with the PN sequence. Now whatever sequence you are using at the transmitter side, same sequence can be used at the receiving side. So that operation we are calling as D-spreader. Now from this D-spreaded sequence, we need to recover our original message signal. So we are using the demodulator. So it is PSK. What is PSK operation? We can how you can demodulate signal? That is by using coherent detection. What is coherent detection? Multiplying the incoming signal with a locally generated carrier signal and passing that signal through a low pass filter. You can recover the original message signal. Why you are using a low pass filter? Why? Because our original data will be the low frequency signal. And whatever PN sequence, so it should be in synchronous with that of the sequence that you are used at the transmitter side. If not, we cannot get at the receiving side. This is one example of the direct sequence spectrum 0, 1, 0, 0, 1, 0, 1, 1. Now you can represent, you have different coding formats to represent the binary data. So I have represent 0 with the high level, 1 with the low level. So you can use any sequence or any format for encoding this one. So this is the sequence 0, 1, 1, 0, 1, 0. This is the PN sequence that you have used at the transmitter side. So XOR of these two, you are getting the transmitted signal. This is the spread spectrum signal. Now all these operations is done at the transmitting side and these operations are done at the receiving side. So this is pseudo-mass signal that you have received at the receiving side and this is a PN sequence. Whatever PN sequence you have used here, this is nothing but the same signal that you have used at the transmitter side. You should use the same signal. If you are not using the same signal, then you cannot get the original signal. So XOR of these two, again you can get this is the signal that is obtained. Now when you compare this signal with all of this transmitter signal, both are same. So this is 0, 1, 0, 0, 1, 0, 1. This is the signal that we have received. Now applications of direct sequence spectrum, anti-jamming capability, CDMA and ranging using direct sequence spectrum. Anti-jamming capability, this is most commonly used in the military. Nothing but when the enemy, when they are intentionally transmitting unwanted signals in the same frequency band in which signals we are transmitting, this is nothing but the jamming effect that can be avoided by using this spread spectrum where the narrow band signal will be converted to the wide band signal. And other one is direct code division multiple access. Code division multiple access is one technique of multiple access. You have different types. Here time division multiplexing, multiple access, frequency division multiple access. Other one is code division multiple access. And ranging using direct sequence spectrum. The ranging is nothing but finding the distance of a spacecraft. Next. So this is the one example of the code division multiple access. This is the code that we have used 1, 1, 1, 1. C1 is 1, -1, -1, 1. And user 0 is transmitting symbol A0. User 1 is transmitting A1. Now this I am transmitting by using CDMA. We are using different codes which are orthogonal to each other. So I am using these two codes. So multiply this one and add this one. So 1, -1, -1 and 1. So the resultant is 0. That is, it indicates this is having the orthogonality function. Now why we are using the orthogonality function? Because here we are transmitting the symbol 0 and symbol 1 at a time. So at the receiving side, we should get only the symbol. If you want the symbol that is transmitted by user 0, we want only A0. So the interference that is caused by A1 can be eliminated when the codes that you have used are orthogonal to each other. So how you are transmitting? Now A0 is multiplied with this code. So we are getting A0, 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 A1. And A1 is multiplied with this code. So A1, -A1, -A1 and A1. Now this is the transmitter code. You are adding these two and you are transmitting. So A0 plus A1, A0 minus A1, A0 minus A1, A0 plus A1. This is the code that is transmitted. Now at the receiving side, we want the original data. We want the original data. So the receiving side multiply with the same code. Multiply with the same code and add this one. So A0 plus A1 plus A0 minus A1 plus A0 minus A1 plus A0 plus A1. So here minus A1 plus A1 minus A1 plus A1 will be cancelled and the remaining is 4A0. Similarly, in order to get the user one, you can multiply with the code that is used for the C1, you can recover the 4A1. Hope you have understood this video, and from this lecture I want to ask two questions. One is, what are the applications of directed sequence spread spectrum and what is the disadvantage in the directed sequence spread spectrum? Thank you.